Hey everyone. So we're going to do a simple tutorial on calculating empirical and molecular formulas given the percent composition of atoms in a compound and the molar mass of that compound. So our question reads, a compound is 40% carbon, 6.67% hydrogen, and 53.3% oxygen by mass. The molar mass of the compound is 180 grams per mole. What is the molecular formula? So the first thing we're going to do in solving this problem is we're going to assume that we have 100 grams of our compound. Why do we do that? Because if we have 100 grams, we know that since carbon is 40%, we're going to have 40 grams of that 100 grams being carbon, 6.67 grams of hydrogen, and 53.3 grams are oxygen. So let's plug those numbers in. So my carbon, hydrogen, and oxygen. The masses I have are 40 grams, 6.67 grams, and 53.3 grams. I'm going to exclude units because Excel gets really fussy when you have a letter with a number and you try and do calculations, and it's going to give you an error. So I'm going to exclude my units and I'm going to assume they're there. And just for convenience, I'll put them down here. So these are the masses of my atoms, but remember, each atom on the periodic table has a different mass. So simply by looking at this data, we can't derive how many carbons or hydrogens or oxygens we have in our empirical formula. What we have to do is convert it to moles. And how do we do that? Well, we know that the molar mass of carbon from the periodic table is roughly 12 grams per mole. Hydrogen is roughly 1 gram per mole, and oxygen is roughly 16 grams per mole. Now on an exam, you want to use the actual values that are cited in the periodic table. So for carbon, you're going to use 12.011, hydrogen 1.008, and oxygen 15.999. However, since we're doing an empirical and molecular formula problem, usually these problems require some rounding anyways, so these estimates are perfectly acceptable. Now these are in grams per mole over here, and this is in grams. Through some simple algebra of the units, you can find that if I take grams and divide it by grams per mole, my grams end up canceling out, and I'm left with moles on the top, so my final value is going to be in moles. So let's do that. I'm going to take 40 grams and divide it by 12 grams per mole. And that tells me I have 3.33333 moles of carbon. I'm going to copy this, and I'm going to paste it. Why did I do that? Well, I did this operation on this top line. Now, if I copy-paste this formula, it's going to perform the exact same operation with cells in the same place on the next line down. And as you see here, it did the exact same thing in row 3 as well. So that tells me how many moles of carbon, hydrogen, and oxygen I have. I want whole number equivalents. How do I get whole number equivalents? Well, the best thing that I can do for my next step is just find the smallest value over here and divide everything by the smallest value, which down here is 3.33125. Why do I do that? Because if I divide this by itself, I have a value of 1. So I know that at least one of my atoms is going to be in whole number integers. So let me do that. E3 divided by E3. And I'm going to make this an absolute reference. Why am I doing that? Well, these dollar signs over here say that whatever I'm performing this formula on, always use this value, E3, as the denominator. So I'm going to copy, I'm going to paste, and look what it did here. It took this number and divided by E3. It took this number and divided it by E3. And that has to do with the dollar signs. The dollar before the E says, use the value in column E. The dollar in front of the 3 over here says, use the value in row 3. Okay, and these look pretty good. So this is 1, obviously, this is 2, and this is close enough to 1 to where I can round. Now, what does this say? I've got my simple whole number ratios. This tells me that in my empirical formula I have 1 carbon, 2 hydrogens, and 1 oxygen. So my empirical formula that I abbreviate EF is going to be CH2O. Now my molecular formula is derived from this empirical formula and the molar mass of my compound which was given. So how am I going to go about getting my molecular formula? Well, first thing I need to do is figure out the mass of this empirical formula unit. So I have CH and I have O. I have 1 of these, 2 of these, and 1 of these. I know that the molar mass of carbon is 12. I know of hydrogen it's 1, and of oxygen it's 16. and I'm simply going to take the molar mass multiplied by the number of atoms I have in my formula. So this times this equals this, copy and paste, and it applies that function to the associated values. And then I take the sum of this, and this gives me the mass of CH2O. Now, I have a molar mass of my compound of 180. I need to figure out how many of these CH2Os I have in my overall molecule. How do I do that? I'm simply going to take this 180 and I'm going to divide it by this 30. And I get a value of 6. And what is this 6? So if I take this 6 and I multiply it by CH2O, I end up with C6H12O6. This is my molecular formula. These are my number of formula units. In other words, this is how many CH2Os I have in my overall molecule. And that's calculating molecular formulas.